Good morning, everyone. It's really a pleasure to be here. My name is Matteo Trascinelli, and as I was already, overly mentioned, I'm responsible for investments into energy industries division. I wanted maybe to, as we are discussing partnership, and some of you, I'm pretty sure that know very well the ABB group. Others might know ABB a little bit less. So, as a group, we have a long history, but we are also a relatively young company. I'm pretty sure that in our current form, some of your companies, the companies that you are representing, have probably a longer history. So in the current form, we have about 35 years of history. And it's also very important to introduce the session about inorganic activities to stress that actually ABB came into place as a big merger. And we have basically M&A into our DNA. So ABB was the merger of ASEA and Brown Boveri. Took place in 1987, was announced in 87, took place in 88. Our two predecessors, large group, have very long history. You go back 2 centuries basically, with ASEA being founded exactly 140 years ago in Sweden. Brown Boveri was established about 10 years later in Switzerland. And today we are a group of about 30 billion in revenues, to give you the size. We operate in 100 countries. We have a market cap of approximately 60 billion. I have not checked lately, but around about that order of magnitude. And we have 4 business areas also to help you visualize where we as blending and formulation, as well as process automation, sit. We have 4 business areas: motion, electrification, discrete automation, and robots. And then the one we belong to is process automation, represent approximately 20% of the entire group. So roundabout, give or take, 6 billion in revenues. And Colin has, we are kind of direct access to the process automation executive committee member and president of process automation. So that's pretty much, to give you a picture where we sit in the company. Question? So when we look to partners, as Colin was stressing also for, in terms of, suppliers and, commercial relationships, we have definitely zero tolerance when it comes to behaviors that would not be fitting with our view of integrity. And specifically, we have we place paramount importance to health and safety. We believe that all our associates, and as well as the contractors, and as well as the suppliers, employees, needs to kind of get back home the same way they came to work. So we look at top class. We demand top class health and safety compliance in our premises, and we expect the same with our suppliers and contractors. As well as human rights, anti-bribery, antitrust, anti-counterfeit. So those are aspects that any deviation will be basically zero tolerated. And it's even more important when we invest into companies. So as a prerequisite of any of our investments, we would do very extensive integrity due diligence and safety compliance audits. So that's is like there is no room for maneuvering in those kind of topics because it's expensive and because, well, first of all, we really feel that it's the right way ethically to conduct business, and second is any mistake in those kind of areas could be extremely expensive, especially in a large group, in terms of reputational risk, and also, all sort of, and rightly so, fines and fees and legal troubles for years and years, if not decades. So we really, are keen to stress this point. We will, not tolerate, and we will have very high scrutiny on, the rightmost item in this chart. I might have pressed the wrong button. Sorry. Yeah. Thank you. So when we look at partners, it's important to find mutual benefits, right? I mean, we can establish a partnership whenever we can, provide something to the partner, and vice versa. When it's kind of unidirectional, and we attempted some of those in the past, but it kind of doesn't work. It needs to be kind of there is something the partners is looking to get from us, and there is something that we are prepared to give to the partner. And we have a few examples of partnership that we have completed last year. And I guess those, time will eventually tell, but we have high hopes that those are actually cases whereby there was a high complementarity between what we can offer and what they were proposing to offer in front of the customers. Because eventually the goal is to have relationships that can, foster customer satisfaction, which typically you can, get recognized in terms of premium pricing, hence, profits and well-performing companies where colleagues are pleased to work for, so then companies that ultimately can attract the best talents, which then will be a self-fulfilling prophecy because, with the right talents, you can further innovate, make the customer even more satisfied, and will be basically a virtuous cycle that would benefit both ABB as well as the partners. As I mentioned last year, as division, we've been pretty active. We have scouted a lot of companies and opportunities. I would say probably something in the range of, well, depends what we mean scouting, but 50 to 100 companies we've been interacting with, and we ended up doing 3 investments. And I will talk more about Coolbrook, was the one that Colin hinted before. There's also, our faces are down in that picture. So that's a few more slides. I'll get deeper into that one. We have also invested into electrolysis of water technology at scale. You see in the picture, you might recognize that's the Canadian Prime Minister and the German Chancellor. That was the day we actually signed that agreement. And we have also invested into the software space for carbon capture and storage, which is something that we see is not yet materialized, I guess, but is highly likely will materialize. Large infrastructure for carbon capturing, and especially the logistics that is connected with it. So basically moving carbon in high quantity. So basically pipelines of carbon dioxide back to reservoirs that can accommodate it in huge quantities as we would need. So obviously the space that we have covered is clearly into decarbonization technologies. And typically those kind of technologies are followed by startups or young companies that are proposing an attractive technology that could help solving that kind of problem. When it comes to blending and formulation, this was already mentioned before. We have some established segments. Pulp and paper, we lost a little bit track of it in the last couple of decades or 1.5 decades, but we still have a huge, impressive installed base there. And certainly any one of you that have experience into pharma, food and bev, fragrance and flavors, cosmetics, detergents, or consumable households product would be very interesting to kind of get in. Absolutely.
Can you go back one chart? Just go back one chart. So what's in common on this chart is that these are all energy transition investments, right? You probably figured that out. It's a core part of our strategy going forward is that we become like a day zero player in the energy transition. So are we going to manufacture electrolyzers? Are we going to manufacture e-crackers? Are we going to manufacture equipment that goes into carbon capture? These are all things that hopefully, resonate for you. And as Matteo mentioned, if you're going down the sustainability path within your own organization, that's only going to help us. We publicly released our first sustainability report as a company this year, right? And there were suppliers that factored into that. So I just want to try and connect what Matteo has said directly to what might be important to you.
Yep, thanks, Colin. I mean, this industry, the decarbonization need will be into the trillions, right? So it's kind of is a gigantic growth opportunities, I guess, for everyone in this room, depending on the slice of, no one will provide the whole solution, right? I mean,
yes.
Everyone will have to provide their own, to put, common factor, their own skills, their specific skills that can be deployed into this potentially, hugely.
Yep. And just to clarify, so we made a cash investment into each one of these, and now we're trying to figure out who is going to help us in the manufacturing side of what we have committed on the commercial or investment piece. So that's all of you. Yeah?
Any questions?
We have a question. Oh my God. Pass him a microphone. Hurry up before he changes his mind.
Hello.
Hi.
This electrolysis you're planning to manufacture where?
That's a great question. The answer is hopefully in this room. We don't have an answer yet. These are early stage. The majority, all three of these were made second, third quarter last year. So we are now in the pilot and commercialization state for essentially each one. So at scale manufacturing is a question mark for every single one of these. His question was, where are you going to manufacture? That's going to depend on finding the right partner, getting aligned early, and figuring it out, right? Yeah. Thank you for that.
So that company.
Is this close to you, or are you close to one of these, or can you give him back the microphone for a second? So are you connected, or you intend to be your business connected to this kind of sustainability area?
Yeah, we're working on that particular project, like for electrolysis. We as a company are manufacturing stainless steel tubes and pipes.
It's not on. I think it's not on. It's not on, right? There you go.
We are actually working on a project for electrolysis, as we are a manufacturer of stainless steel tubes and pipes associated with the ABB or the peat industry,
Okay.
supplying the peatable pipes.
Okay.
Yeah.
So here we are actually also working with some companies like Reliance, who are actually coming in a big way for this this green hydrogen.
Yeah.
So we are working.
Yeah, that's
with
exactly obviously for green hydrogen. It's electrolysis of water to produce green hydrogen, right? So, I mean, the company is Canadian. The first like blueprint manufacturing location will likely be in Ontario, where they are based. However, strategically, we don't have the strategy of from Ontario to the world. It would not make sense. So as this industry will grow to gigawatt size, we will need to be closer to where the demand will be. And although there is some demand domestically in Canada, which is great, but there will be bigger demand into other areas of the world, Middle East, India, Australia, Chile, those are the places.
So think back to what we said in the first hour. So we said global execution in this building. That applies to our current portfolio, and it applies to our ambitions in future portfolio. So if you have skill and know-how in this space, we need to figure out how to get aligned on where we can help each other. Yeah. Thank you. Thank you. Oh, great. There's caffeine. If we need caffeine, we can get some caffeine.
Yeah, my question is, you're going to stop only at the generation of hydrogen, or you also intend to take up, compression of hydrogen? Because we are already working on some projects wherein we are compressing the green hydrogen to very high pressures, like up to 700 bars.
Yeah.
And for gas injections into various automobile sector.
Then I definitely guess we should exchange business card. We definitely are interested also to cover the compression phase into the what I would call the electrolysis island. So we would go. I mean, as ABB, we are directly supplying the rectification unit, so the AC to DC power converter. That's our what we sort of manufacture as ABB. So for that component, we are the OEM, but we are also looking holistically at the entire system. So and even beyond the compression of the hydrogen, then you move into air separation unit, Haber-Bosch reactor to make ammonia, or then whatever is the downstream, could be methanol or synthetic kerosene or whatever else, right? So we would then cover from a process automation standpoint the entire plant in that case, from an automation standpoint, not the whole thing. So definitely will be more than pleased to join forces on the compression.
What is your business?
We are basically into modular skid packages. So we are presently doing hydrogen compression packages, wherein we are getting the compressors from US and doing the complete packaging and supplying to Indian Oil Corporation for one of their Faridabad units, which they have a R&D facility where they're going to use this high pressure hydrogen for Toyota Mirai.
Okay. And what are you delivering to ABB currently?
Currently, we are doing some blending skids for ISL.
Okay, thank you.
Yeah, I think then, your support will be also very relevant into Coolbrook.
Yes.
Because as you will see in the next couple of slides, our joint system, which is the e-cracker or the Rotodynamic Heater, depending how you configure it, is basically the same product, but it has a little bit of different configuration, depending what's the application, whether it's in cement or steel or versus chemicals. But you will see that it looks pretty much like a compressor. So that's in terms of the collaboration on supplies for the ABB plus Coolbrook partnership. I would, for simplicity, I would invite all of those of you that are already working for some compressing applications to look at it like a kind of a compressor. So I guess the contents of the slides are probably well known to most of us. We are, as you know, humanity, as in the last couple of centuries, have discovered that there are some energy down there in the ground that was stored for 100 million years, and it was pretty nice to get to tap into it. And the only issue with that is that we are increasing the concentration of carbon dioxide into the atmosphere, plus a few other disadvantages. However, it was absolutely the key inflection point into global population growth and increase of the living standards. This is undeniable.
Yeah.
Now we need to find a solution on how to preserve those while stopping or at least reducing venting carbon dioxide and a number of other pollutants. Well, carbon dioxide as such is not a pollutant, but the other stuff is into the atmosphere. And typically, a lot of the pollution happens in the form of firing. So we burn coal to run power plants. We burn coal into cement plants and gas. We burn a lot of gas into cement plants. So there is the largest contributor to carbon dioxide emission is actually industrial use. So I think the single largest contributor is actually cement, followed shortly by steel. Big portion also into chemicals, like something like 3% of the total emissions, which is huge. Because 3% of total emissions is basically comparable to the entire aviation industry, just to put in perspective. And the cement itself will be like 2-3 times the global aviation industry, just to put in the right perspective. And we have been told that those segments are hard to abate. Why they are hard to abate? Well, because they require very high temperature. Talking of 1,000 degrees Celsius or more. The main calcination of limestone happen at like about 1,500 degrees for the cement industry. So this kind of such high grade and high temperature heat that is not trivial to electrify. And so the main solution or hope could be through hydrogen, for instance. You can burn hydrogen, but hydrogen is not existing in the first place, and that's why there is big investments also going into the green hydrogen industry, and we have done that investment as well. Coolbrook came up with the idea of utilizing a rotating machine to achieve that. And we partnered with them because, obviously, as I've shown into the chart earlier, we are a leader into motors, drives, so power converters for variable frequency drives for electrical motors, and automation technologies that will go with that. So, fast response time automation technology that would govern the drive, so then the rotating machine is perfectly tuned to what is expected to do. And with that rotating machine, you could think in simplicity, it's basically a compressor with 0% efficiency, meaning a compressor that transforms all the mechanical energy provided to it into heat. And you can, with their technology is already, proven, and there is pretty impressive. There is a picture coming up. Pilot plant in the Netherlands into an industrial setup. It's a large petrochemical facility, and there we are, together showing the potential of this technology. So, kind of compressor, 0% efficiency turns the whole energy that you provide to it, megawatt, so potentially megawatt or tens of megawatts, into very high grade, high temperature heat, which you can then deploy it into e-cracking, so electrical cracking technologies for instance, naphtha turning into ethylene, or cement manufacturing, or steel and metals manufacturing. Is coming in two variations. One is the rotodynamic reactor, where is meant to have both heating as well as reacting processes happening inside the same enclosure, basically, minimizing the residence time of the naphtha, for instance, in the naphtha to ethanol ethylene reaction, which would have higher yield and better energy efficiency fundamentally. Or into the rotodynamic heater, which is the primary goal is to produce very high temperature heat, and ultimately, to temperature up to 1,700 degrees Celsius, which would then be sufficient to electrify the entire cement process. Obviously, cement, some of you might, mention that, and rightly so, cement, the carbon emission out of cement are actually twofold. One is about approximately 40% is because of the heating, which this solution will solve. 60% is about the process. So the calcination itself, once you heat up and the limestone and the calcination reaction happens, it releases carbon. So that one, obviously, this technology will not solve, but there are, then potentially other technologies to kind of capture it or do something with it. Anyway, if in the single largest carbon dioxide emitter, you are reducing 40%, if you do simple math, you are basically as if you are decarbonizing the equivalent of the entire aviation industry in one go, with one machine, basically. So that's, gives you a little bit the proportion. This is, potentially huge. I already mentioned we felt that, I guess this is a good example of what I was saying earlier, is the complementarity that would make a partnership successful. So they were designing, so Coolberg designed this machine, the rotating machine, the mechanical part, and we had our established motion and with motor and drive and automation technologies and the rest of the electrification and the advanced analytics that would go with it. So it was just, a partnership calling calling for action was so natural. When we saw it about 1.5 years ago, we was kind of, Colin and I were on a phone call and said, well, this kind of, we concluded that this was obvious, that we had to kind of join forces. And so it was also very easy to establish a connection with them and create this partnership that, again, time will tell, but we see a lot of promising prospects in all the three segments. So customers are enthusiastically speaking with us about this technology. And customer door, when we present this, are always open.
Yeah.
They're always, willing to listen from us. So this, I guess, I already covered.
Yeah.
The potential for decarbonizing is just gigantic. This is the picture. This is a picture taken, in the Netherlands. That's still, kind of a pilot, is about 1/10 of the size of a commercial unit. Is, however, very important that is installed into an industrial setup, because it would prove not only the concept itself in the machine itself, but also all the auxiliaries. And they are expecting, I mean, the heating potential has already been proven.
Yeah.
I guess when Colin and myself were there in December, the machine just in the first startup, quickly in about 20 minutes, I mean, in 20 minutes, not to stress much the metals, obviously, because as you know, you need to kind of heat up slowly, but in 20 minutes they reached easily 550 degrees Celsius. And so it was pretty impressive, and a number of customers were there. And later in the springtime, beginning of summer, they will also fire it up with
naphtha,
with the hydrocarbons to test also the reacting potential. I mean, to test the use of the same machine as a reactor as well, in addition to a heater. So while perhaps in the picture it's not fully visible, but obviously there's a motor and a drive connected with it. So the machine is relatively compact. Again, that's about 1/10 of a commercial-sized machine, but it's basically it's a rotating machine. So it's like if you have experience into providing skids or other supplies for compressors, I guess those would probably be pretty redeployable. So we're kind of look for partners to help us moving from prototype, potentially a commercial prototype or pilot, into industrialization, which is clearly, the next phase for this, and we are about to be ready for that phase. Yeah, as mentioned here. And this is once again the complementarity of the scope of supply.
I could add something here if you want.
Sure.
Yeah. So we have never had a cracking technology. ABB is not in the petrochemical cracker business, historically speaking. Partnering and working in this development of electric drive furnace, whether it's cement, steel, or petchem, will give us, if you go back one chart or two charts, I think it was. So our, keep going, one more. So right here. So this left column is basically a fair amount of product that we are very, very good and comfortable putting into market. We've been doing this over 100 years. We intend to keep doing it. And part of our agreement is that ABB has kind of carved out a specific product requirement that would feed into this RDR or RDH. The part Matteo's getting at is we don't have a manufacturing partner, and we need several in order for this to establish itself and get off the ground. That's an opportunity for you. Society-wise, we think energy transition, which, by the way, this isn't the first one, right? I mean, we started out maybe burning wood, and then we went into steam and coal and gas and eventually oil. And now I think this next step of energy transition looks a lot like electrification, but it's not the only solution. It's part of the solution, right? But we are really embedded in this space. And I think if I heard a few people here in the audience kind of saying, hey, that sounds like something that we could really get good at, or maybe is similar to what we've done in the past, and we invite you to kind of get connected to Matteo on this topic. We can also get you involved in the pilot. We're quite close. We're connected with Colebrook pretty much weekly, I think, at this point. There are several partners here in India, specifically in cement, that have already signed on for pilots. Some of that is a little bit NDA type stuff, but if it's really kind of in your sweet spot, we can make sure we get you the information that you might need on some of this stuff. They've been very active here. I can tell you they've been very active here for good reason. I don't think I have to explain that to you. So think about how this looks to you, whether it makes sense to you. Why does it matter for blending? Well, if you are already today producing and manufacturing product at a high quality, and we all really like each other, which I think is the case, I hope, why would you not want to go with us into another market? Why not? It would only make sense. I believe this is going to be like the next bigger thing. I honestly think it's closer than hydrogen, if I'm honest with you. I think there's a lot of dreaming happening in some of the hydrogen stuff. No offense to any hydrogen people that are in the room, but I've seen a lot of these projects and frankly haven't seen a whole lot of money, if I get to the point. But there's a lot of big stuff that's out there and lots of websites and PowerPoints and stuff. And I hope it does become part of the solution. But I'm a little maybe skeptical, at least for now, as to not the solution itself, but whether it can be a profitable business more so than anything else. Because the projects I've seen have been at such a horrifically low margin, even if we wanted it, I'm not sure we would take it. So think through what that means to you. If you have questions on this, I would come back to Matteo. There's a question here in the back. If we could pass a microphone back there, that would be super. And we're happy to take a few other questions on this topic. I think it's a good one.
My question is, because most of the petrochemical technologies in gas cracking or naphtha cracking, the licensors generally provide the cracker, when basically the cracker technology, like just like you have Technip, you have Lamos, you have Topso, who are into this business. So generally when they give a guarantee for their process, they give the process technology along with their fired heaters and crackers.
Yes.
So is ABB planning to already tied up with them, or how it is going about? And my second question is, because these cracker technologies are going in a very large scale, like earlier we used to have a 500 ton per annum cracker, but presently people are going even up to 1.5 million tons per annum to 2 million tons per annum. And presently we are working with one of the top petrochemical companies which are going to set up a 1.5 million ton cracker. So I just want to understand, like, what is this pilot size, and how are you going to exponentially take to the requirements, and whether you have already tied up with the licensors?
So there are two licensors that have already signed on to this technology. One has been released, I believe. If you go to the Coolbrook website, you'll find it. So that your point is completely accurate. We are not in the licensor business. We used to be way back when we had Loomis and all that kind of stuff, and decided that the EPC and licensor business was not kind of like a core business for us. But your point remains a fact that in order for us to get off the ground with Coolbrook, we are going to need partnership with licensors. Part of what ABB has brought to Coolbrook is some relationship in exactly the area that you're pointing at. If you want to go through the size and scale of the pilot and dates of when we start cracking naphtha, we're happy to kind of do that in a smaller setting for anyone that wants to be a part of that. Okay?
Maybe just
thank you for
adding
that.
one point, Colin. You know, the scale is huge and it will not happen overnight, right? So tomorrow will not be, you know, all the e-crackers, that's clear, right?
Yeah.
However, this technology, and that's why it's so attractive for established chemical players, because as we all know, with exception of some geographies, some specific geographies, but in many geographies, you would not go out and build brand new petrochemical plants. And typically the cracker is the centerpiece of that plant, right? the beauty of this technology is that it's extremely compact. So compared to a traditional cracker based on a burner and all the pipes and TLEs and whatever, this solution is way more compact compared, with the same throughput. So it can be a great candidate also for brownfield retrofitting. Now, obviously, you cannot just go there and cut the whole thing out and place the equipment because the site is producing, so you will need obviously to have some scheduling of that and so on, right? But it is possible because the footprint is, significantly smaller. So it would for sure fit into into a replacement of an existing furnace into an existing petrochemical complex.
Yep.
Yep, another question, please.
Hi, is everybody able to hear me? My name is Anish. I'm operations engineer for a company called Sotish. We are based in Goa. So I've been working with this company for the last 7 years. It's been started by my father. He has been starting this company 40 years now. I would like to first thank people for us to get a lot of very rich environment, and the interactions that we've had with the very few players that are there have been very rich. And so my first question, I think it's both to Colin and Matthias, to you also, that since this is a very rich environment and people are there, provide different kind of solutions, how is ABB working to get everybody involved? Like how can we have this process to process, different people coming together so that better innovation, and also how can we leverage ABB's own innovations in these fields in a better way? And secondly, with regards to technology where we are producing suppose green cement in a way, have you looked at some solutions which are in a biomimicry sense? There is a company called Blue Planet Systems, and they have been very active in this field for studying organisms in the ocean who are already sequestering carbon dioxide and making cement. So I think this technology, along with those kind of innovations, would be very helpful.
Yeah, so let me get started from the second question. Yes, we have been looking at this kind of technologies, which obviously will take care of the 60% of the emissions that are caused by the cement, which is the one that is kind of intrinsic with the process itself, right? So the moment you burn limestone and produce the calcination, it will emit CO2. There's nothing that you can do about it, or unless you are kind of closing the loop with those microorganism algae that are basically doing the calcination. They are doing the other way around and providing you with the starting product, right? So I've been actually meeting a couple of companies that are proposing that concept, and I think is extremely attractive. It's a little bit more far away from what we do in terms of complementarity, because we do motors, drives, and automation, and but certainly there's an angle to kind of complete the decarbonization of cement. In regards to the first question, well, I guess that's exactly the purpose of an event such as this. Obviously, this kind of emerging industries are complex and they require a lot of supplies. So beside the main machine, then there is the skids, all the utilities, cables, is huge. Then the full supply chain needs to be kind of coordinated accordingly, and that's primarily the purpose of this event, to try kind of establish connections.